Hi, in this segment we're going to be looking at acceleration graphs. So what I'd like to do is first look at these two velocity graphs. Now remember, velocity graphs show your speed or velocity over time. And when you find the slope of these graphs, you're going to have your change in speed or velocity over time, and that gives you your acceleration. So if I look at this graph over here, I've got this slope here. It's a nice positive slope, so I've got a positive acceleration. That tells me that my velocity is getting more and more positive. In this one, I've got a nice constant velocity. And with a constant velocity, I don't have a change in motion. And I look at my slope, it's zero. So I've got a zero acceleration associated with this. So let's take a look at some of the velocity graphs just underneath here. So first of all, again, let's look at the situation where I have a nice motionless object. So again, it's a flat line, so my acceleration or slope is zero. And this indicates that my motion is not changing. I'm motionless the entire time. I could also have a nice constant positive velocity here. Again, because my velocity is constant, I don't have any change in speed or its velocity, so my acceleration is zero. This example here, we are speeding up positively, so I'm going more and more towards the positive, so I've got a nice positive slope or positive acceleration, and we are speeding up in this situation. So speeding up. Here, we're also speeding up. The only difference, though, is the slope is negative. So what we're doing here is speeding up towards the negative, or we have a negative acceleration. And finally, in the last situation, we have a large velocity at the beginning, slowly coming to a stop. So I'm slowing down. And you can see here my slope is going to be positive, which means I have a positive acceleration. This makes sense because at the beginning I had a negative velocity coming to a stop. So if I'm coming to a stop, negative velocity, I must have acceleration in the opposite direction, or positive. So all that's left now is to draw a graph of each of these accelerations on an acceleration graph. These are really easy. You can see here that when I have a zero acceleration, it's always zero. So just draw a line right along here. Again, zero acceleration. Here, my velocity graph has a nice constant slope. When I draw that slope down here, it's positive. It's going to be nice and constant. It doesn't change. So I have a nice constant acceleration. Here, same thing, this constant slope, it's negative, so I've got a negative acceleration. And finally here, it's another positive acceleration, positive slope. So positive acceleration. And that's all there is really to these graphs. So acceleration graphs are always horizontal, they're flat. They can be zero, so zero acceleration. They could be positive or they could be negative, depending on the situation. So now that we've done this, let's take a look at all three graphs for different types of motion. So what I have here is I've got situations where I have zero acceleration. This indicates that the motion is not changing. You either have a constant velocity or you're motionless. So let's look at a situation where we're motionless. So when I'm motionless, my position is not changing, so nice flat line, and this is indicated by zero velocity, and again, zero acceleration. I'm not changing my speed or velocity. And it makes sense, zero slope, zero slope, zero slope. Okay, what if I'm going at a constant positive velocity? Well, here you go. Nice even increase in my position, so nice constant slope. So that's a constant velocity. The same thing appears on the velocity graph. And because my velocity is not changing, acceleration is zero. Finally, if I have a nice constant negative slope, so my position is going towards the negative, nice and constant, or nice constant negative velocity, and because it's constant, again, there's no acceleration. So all three of these show no change in motion. Let's look at situations where we do have changes in motion. So here we've got an object where objects are going to be accelerating positively. They're increasing the velocity in the positive direction. So first one, I'm starting at rest. So initially motionless with a positive acceleration. So my slope here is increasing. Remember, slope is indicated by the speed or velocity. Here my velocity is increasing and my acceleration is positive. This is a nice constant increase in the velocity. So nice flat line here. If I already have a little bit of a velocity, I'm just going to have a little bit of a slope on the position graph. So I'm already moving. And a velocity graph is starting above zero. So it's up here. And the acceleration is still positive. It really doesn't change. Now, if I have an initial negative velocity and positive acceleration, I must be slowing down. So here's my negative velocity. Gradually, the graph is leveling off to 0. Here, same thing, negative velocity, graph is going to 0. And because it's a positive slope, positive acceleration, I have a nice flat line on the acceleration. So, okay, just to quickly recap, the acceleration graphs are always horizontal. Velocity here, because of the change in motion towards the positive slope, positive acceleration. Okay, what happens when we've got a negative acceleration? Well, negative acceleration basically means you're getting larger in the negative side of things. So I can have an object initially motionless with a negative acceleration, so I'm not moving. The graph gets steeper and steeper towards the negative here in the position. Velocity, my velocity gets more and more towards the negative at a constant rate. And my acceleration here is nice horizontal, negative. Again, that's because the slope of the velocity graph is nice and constant. Now, if I already have a little bit of a negative velocity, my slope is already negative here. I have a negative value for the velocity graph, but then the velocity keeps going negative, just like the previous one. And my acceleration is negative. Now, if I already have a positive velocity, I'm moving towards a positive, and then I have a negative acceleration, I'm basically slowing down, becoming less and less positive, more negative. Here's the same thing, positive velocity coming to a stop. So remember, here we've got a negative acceleration. So negative acceleration will be indicated like this on the acceleration graph. So again, acceleration graphs are always horizontal. The velocity graphs here are all pointing down negatively because they have a negative slope, negative acceleration. And then the position graphs are either increasing in steepness if you're speeding up or decreasing in steepness if you're slowing down. And that's it.